What is a pi bond? There are two types of covalent bonds. One is sigma bond and another type of bond is called pi bond. What is the difference? Difference is in their formation. A sigma bond is formed by head-on overlap between orbitals, and a pi bond is formed by sideways overlap between orbitals, right? So, which one is a stronger bond? Sigma bond is a relatively stronger bond than pi bond. Pi bond is more reactive, sigma is less reactive, right? And there is another aspect to this. In bonding, you will see the type of covalent bonds, as I explained you, on the basis of overlap you have sigma and pi bonds, head on overlap sigma and sideways pi. Similarly, on the basis of type of donation, there are two categories. One is covalent bond, normal covalent bond, in which what happens is, if there is a bond between A and B, one electron of this bond is given by A and one electron of this bond is given by B, and these two electrons belong to A as well as to B. Mutual sharing is happening. But there is another unique type of covalent bond which we call that as coordinate bond or dative bond. Coordinate or dative bond. It is a type of covalent bond only the formation is different in these. What happens in them? In them, something like this happens. If we have a bond between A and B, let us say two different atoms, in this both the electrons belong to one atom only. These two electrons are of A, either A or are of B. That means donor atom in such type of covalent bonds is 1. So, this is type of bond is called as coordinate bond or dative bond. It is after formation, these two electrons will belong to A as well as to B. After formation, coordinate bond is same as covalent bond. That means the bond between two atoms will be shared by each, but the difference is in the formation. The difference is in the formation. In a covalent bond, normal covalent, each atom will contribute one electron and both electrons will be mutually shared. And in coordinate bond, what happens is only one atom out of two atoms, only one atom will give both the electrons, as happens in ammonia to ammonium formation. Let us say we have ammonia molecule, NH3, there is a lone pair on N, and then comes H plus. H plus says to N, you have extra lone pair, can you give me? So, nitrogen says, okay, you are coming to me, I will definitely help you. So, it forms, this nitrogen forms a coordinate bond with this H. So, it is like this. These are normal covalent bond. In these, one electron is given by nitrogen, another by hydrogen, one by nitrogen, another by hydrogen, one by nitrogen, another by hydrogen. But it will form a coordinate bond like this. In this, both the electrons are coming from nitrogen only. So, such type of bond, and the donor atom gets a positive charge and acceptor gets a negative charge, H plus already. So, this charges cancel out, you get NH4 plus. So, in such type of bond, coordinate or dative bond, the donor atom is 1. After formation, it is just like another covalent bond in which both the electrons of the bond are shared mutually by each atom. So, these are few explanations on coordinate bond. Now, you can observe the same in H2O2 structure, ozone formation, carbon monoxide formation. In carbon monoxide, what happens? I will explain it to you again. Carbon monoxide has this triple bond, right? So, now this carbon has a lone pair. First and second, this bond, 2 electrons are given by carbon and 2 electrons are given by oxygen. Each bond has one coming from both, one from carbon, one from oxygen, one from carbon, one from oxygen. But this bond, the topmost bond, is a coordinate bond. Both the electrons of this bond have been given by oxygen only. right. So, this is a coordinate bond. So, carbon monoxide has both type of bond, normal covalent as well as dative or coordinate bond. There are certain molecules which do not follow octet rule, either they have more than 8 electrons in their valence shell or less than 8 electrons in their valence shell, but they occur naturally. So, this was a blow to Lewis octet theory. We will be studying further about this in topics ahead. Alright. So, with this we end this.